Welcome to MARSAL's demo for PoC21 test scenario number 3. The main purpose of the predefined algorithm is to predict the probability that a given user will become an elephant of the network, meaning that the user will start requesting a lot of traffic from the network. To make its prediction, the predefined algorithm takes as input the server name indication, or SNI for short, which is a parameter related to the website requested by the user. The SNI identifier is a piece of code that is deployed as a container in the same pod as we have deployed the UPF of the 5G network. In this same pod, we have also deployed the bandwidth reporter building block, which, based on the output of the predefined algorithm, decides which bandwidth to allocate to the user based on the prediction on whether or not this user will become an elephant. We will now see this scheme in action running in the CTTC testbed. We start by setting up the private 5G network that is featuring Open 5GS for its core part. The RAN, which in this case is based on a Microsoft G-Node B, registers to the Open 5GS access and mobility management function. The 5G network is now ready for the demo. Our solution is a cloud-native elastic deployment based on Kubernetes. Here we can see the different nodes in our Kubernetes setup together with the different workloads that are being executed. These workloads correspond to functions related to the 5G core, to the monitoring system, and also related to the orchestration. If we have a closer look at the different containers that are running in the same pod, we can clearly identify the bandwidth reporter, being highlighted now, the SNI sniffer, and also the user plane functionalities of the UPF. As you can see now, we can use our own private 5G network to surf the internet with the best effort slide. For example, we are accessing CTTC's webpage and also the MARSAL Project webpage. We can now see how, via the SNI, we can detect which are the websites that are being visited by the cell phone. If we now request a high-quality video, our best effort slice, consisting of one PRB, does not support max quality, and then we encounter a buffering situation. In this plot, we can see that there is a traffic bottleneck as we are depicting the UPF traffic reporting for this one PRB allocation, which will be always below 4 megabits per second. We now compare the previous bottleneck situation with that results from equipping our system with a detection of elephant users. In this case, via the building block of the elephant predictor, we can enable a priority slice on advance to support maximum quality. Let's now turn our attention to the flow of events from an orchestrator point of view. We start with one PRB allocation, which amounts to approximately 4.4 megabits per second. Now, the prediction of the predefined, based on the SNI history, triggers a slice upgrade from 1 to 273 PRBs. With 273 PRBs, the maximum downlink bitrate that we can achieve is 1.2 gigabit per second. With this new priority slice that supports peaks of above 200 megabit per second, we can ensure the high quality video reproduction. Whenever our predefined algorithm detects or predicts the end of an elephant behavior of the UE, we can go back to the best effort slice. We can now see the situation from the orchestrator point of view and see how the UPF traffic is significantly reduced. Jaime Fuster from NEC provides now his impression of this collaboration between NEC and CTTC.
I'm Jaime Fuster from NEC Labs Europe. We came to Barcelona to CTTC's premises to help integrate our predefined algorithm into the testbed. with the help of our model, we will be able to allocate resources for users that have a high probability of becoming elephants in their network.
My name is Miquel Pallaró, and I am with the CTTC team involved in the MARSAL project. In this demo, we have seen the advantages and benefits of integrating an analytics engine in the mobile network. In particular, we have seen how the analytics engine allows us to predict when a given user will become a heavy user in the network, and thus we can proactively, and before it happens, allocate the necessary resources so that that user can be properly served. In this demo, we have used a 5G network because we wanted to have an end-to-end demonstration. However, the benefits of the analytics engine can be extrapolated to beyond 5G and 6G networks.